Collins Cobras, this is Mrs. Hernandez from LC62 and I'll be the host of your video lesson. Today we will be talking about using a ratio table to graph proportional relationships. It is important to note that because proportional relationships are multiplicative, which means that they are based on multiplication, the graph of a proportional relationship will always pass through the origin or point 0, 0 on the graph. So if you make a graph of a proportional relationship and it does not pass through the origin, then you need to go back and check your x and y coordinates because the graph should always pass through the origin. Okay, so we've got a proportional relationship here. It says a shower uses 12 gallons of water in 3 minutes. So we're comparing gallons to minutes. Complete the table and graph. So we want to use the information that we do know, which is that it uses 12 gallons in 3 minutes to solve for information that we don't know. Here is where I'm actually going to start on this table because it lists 3 minutes and I know that after 3 minutes 12 gallons of water have been used. In order to find the information that is missing, we're going to find out what is the relationship between 3 and 12, and we know it has to be based on multiplication. So what can we multiply by 3 to get 12? And the answer to that would be times 4. So we can use this relationship for all of the other values in this row. So if I run the shower for 2 minutes, I will use 8 gallons of water. If I run the shower for 3.5 minutes, I will use 14 gallons of water. I'm going to have to skip this one because in all my other relationships I started out with the minutes and I calculated for the gallons. So I'm going to skip this one for a second. And if I run the shower for 6.5 minutes, I will have used 26 gallons of water. When we were going from the top term to the bottom term, it was a relationship of multiplying by 4. This time we know the bottom term and we're working backwards. So to find this missing piece of information, we're not going to multiply by 4, we're going to do the opposite of that and we're going to divide by 4. So when 20 gallons of water are used, it's because the shower was running for 5 minutes. Okay, so then we're going to take a look at this graph right here, and along my x-axis I have a label of time in minutes. So this will be my x-coordinate. And on the y-axis I have a label of water used in gallons, and that's going to mean that this information is our y-coordinate. So we are going to be plotting points 2, 8, 3, 12, 3.5, 14, 5, 20, and 6.5, 26. Alright, we know that when we're graphing, the x-coordinate is always listed first, the y-coordinate is always listed second, and we always start at the origin. Since this is positive 2, it's going to tell me to move to the right 2, and positive 8 is going to tell me to move up to 8. So here's our first point. Here's 3 on the x-axis, and I want to move up to 12 on the y-axis. 3.5 is going to be here in between 3 and 4 on the x-axis, and then up to 14 on the y-axis. Here's 5 on the x-axis and up to 20 on the y-axis. and then 6.5, so here's 6 and here's 7, so 6.5 is going to be in between, and then up to 26 on the y-axis. And if I connect those, I am going to get a line that passes through the origin. Okay, let's take a look at this situation. Sulfur trioxide molecules all have the same ratio of oxygen atoms to sulfur atoms. So we're comparing oxygen to sulfur. A number of molecules of sulfur dioxide have 18 oxygen atoms and 6 sulfur atoms. Complete the table. So we want to use this information that we do know to solve for information that we don't know. So when there are 6 sulfur atoms, there are 18 oxygen atoms. So I can make my first set of coordinates using this information here. And then I want to find what the relationship is between 6 and 18. I know it has to be based on multiplication, so it's going to be multiplying by 3. So then when there are 9 sulfur atoms, there are 27 oxygen. When there are 21 sulfur atoms, there are 63 oxygen. And this time, since we're going from the bottom term up to the top term, we are going to do the inverse of multiplying, and we're going to divide by 3. So when there are 81 oxygen atoms, there are 27 sulfur atoms. Looking at my graph, I see that sulfur is listed as the variable on the x-axis, and oxygen is on the y-axis. So we're going to be plotting points 6, 18, 9, 27, 21, 63, and 27, 81. Alright, so looking at my x-axis, I see that it goes from 0 to 6. So halfway in between 0 and 6 would have to be 3. So I can see that we're counting by 3s on our number line on the x-axis. So that will help me identify some of these points that I don't see labeled. But my first point is 6 and 18. So 6 on the x-axis, 18 on the y-axis. 9, so since we've determined that we're counting by 3s, I can tell that this would be 9 on the x-axis, and then up to 27 on the y-axis would be here. Okay, then 21 on the x-axis is going to be in between 18 and 24, so here, and then up to 63 on the y-axis, 27, and 81. There we go. And once again, if we connect those, because this is a relationship based on multiplication, our graph does pass through the origin. Don't forget to complete the practice page after this, and I hope you have a great day.